Thank you very much, folks. Thanks for being here. My name is Apaji Malla. I'm one of the product managers on the Nexus 1000V team. And along with me, I have Chakri Awala. He is the product manager for UCS. And we have multiple folks from the UCS team here in the audience. We have Timothy Ma. He is one of the TMEs for the UCS. We have Joseph Swaminathan. He is the engineering manager for Nexus 1000V. And we have Sai Chaitanya. He is the TME, technical marketing engineer for Nexus 1000V. So please do stop us at any point in time if you have any questions. We should be able to answer them. Just a standard disclaimer that we are discussing things that aren't introduced yet, so there might be delays, and there might be slight changes in the roadmap, etc. And over the next 75 minutes, we want to cover the Cisco's virtual networking solutions for Hyper-V. Specifically, we want to focus on the two Nexus 1000V for Hyper-V and the Cisco VMFX. And in the first 5 to 10 minutes, I want to briefly talk about Cisco's vision, what problems we are addressing for the customers, and specifically what we have done so far and what we are planning to do over the next couple of years. And then I'm going to jump into a deep dive on 2000V, providing overview of the product architecture, how it's designed specifically for SCVMM, what are the integration points with SCVMM and Windows Server 2012, etc. And then I hand it over to Chakri, and Chakri is going to cover the VMFX solution. Just before I jump in, I want to check how many of you are existing, currently used Nexus products in your data center. Looks like most of you. How many of you use UCS servers in your data center? Oh, almost 50%. OK, great. So from Cisco as a company, we address quite a number of customer segments. We have customers with very small environments, like maybe tens of servers, to large enterprise customers that have hundreds of servers to maybe thousands of servers in some cases. And we have SP customers that deal with hundreds of thousands of VMs. And MSDC, some large-scale data center providers, they basically have hundreds of thousands of servers. Right? So we try to address the requirements for each of these customers have different requirements. Some want security, secure multi-tenancy. Some want high availability. Some want reliability. Some want service orchestration. Some want a very strong partner ecosystem. We try to address the requirements for each of these customers. And the same is the case with virtual networking as well. If you look at virtual networking, some of our customers have problems with their physical workloads working right next to their virtual workloads. In that case, if you have a different operational model across these two different domains, they are running into a lot of operational issues. And in some customer environments, they have multiple hypervisors. They have workloads working on one hypervisor, as well as some workloads running on another hypervisor. In those cases, operational issues crop in, and then that's creating some issues for our customers. In some other environments, in some highly virtualized environments, our customers are looking for very strong services ecosystem. They want firewalls. They want monitoring devices. They want virtual application acceleration devices. And in some cases, customers are looking for how can I better utilize my data center resources? How can I move my VMs, not just across different pods? We want to move our VMs across the data center or across data centers. I have a data center in San Jose. I have a data center in Seattle. I want to move my workloads across these different data centers. And in some cases, they want to move across private clouds and across public clouds, private cloud to public cloud and back. So we are trying to address all of these requirements with our virtual networking solutions. So our focus is primarily to make sure we provide a consistent operational model across all the Cisco devices, whether they're managing the physical environments, virtual environments, or cloud environments. And we want to provide a multi-hypervisor support, where we support no matter what hypervisor you choose, you have strong support from us. And we want to develop a very strong services ecosystem around Cisco's virtual networking solutions. And from a resource utilization perspective, we are coming up with multiple new technologies to make sure you can better utilize your data center resources. So moving on, from a Cisco's vision overall, very high-level vision perspective, a lot of our customers are making this transition from physical workloads to virtual workloads to cloud for obvious financial benefits. And like I mentioned earlier, consistency is one of the key areas our customers are looking for. They want consistency to protect their existing investments and consistency to reduce the risk involved in operating these different environments. And we want to provide that to our customers. And if you look at the switching portfolio that Cisco has, we introduced the Nexus line of products about 4 years back, and they have very strong traction with our data center customers right now. And these physical switches are built on top of NXOS. It's a purpose-built for data centers. It's a highly available, highly reliable data center operating system. And we're bringing that same advanced, highly reliable, highly available operating system to the virtualization and cloud environments through the Nexus 1000V and BMFX. And if you look at the ASRs, the aggregation services routers that we have, this is a very strong, we have been selling these routers for a long time. A lot of our data center customers use these routers. We're bringing the same experience of ASR to the virtualization environments through our CSR, or the cloud services router. And the same is the case with services. We have very strong services portfolio, whether it be WAN optimization, whether it be security, whether it be monitoring. We are either number 1 or number 2 in some of these areas. For example, ASA is one of the most trusted firewalls. We are bringing the same experience of ASA, WAS, and NAM to the virtualized environments through virtual WAS, VSG, ASA 1000V, and VNAM. Again, UCS was purpose-built for virtualized environments, but it works really well for bare metal workloads as well. So overall, our vision is to make sure across the board, across our portfolio, we want to maintain consistency for both physical, virtual, and cloud workloads. From a virtual networking perspective, we want to build a platform that's hypervisor agnostic, that has a very strong ecosystem of network services, firewalls, web application firewalls, monitoring devices, our WAN optimization services. And we want to support a range of private clouds and public clouds. So that's our long-term networking vision, and Nexus 1000V is the backbone for that vision. Coming to the Hyper-V environment, we have a very strong partnership with Microsoft, and we are not just bringing point products to Microsoft Windows Server environment. We are bringing a holistic solution for any Windows Server 2012 workload or use case. We are bringing all the pieces together, our UCS servers, our Nexus 1000V and BMFX solutions, and our manageability solutions in UCS Manager and UCS Power Tool together, and we are creating CVDs, or Cisco Validated Design Guides, that let you develop a Microsoft environment within a very short period of time with reduced risk. And we are certifying our environments for our solutions for different Microsoft applications like SQL Server, we have certified for that, Exchange Server, SharePoint, and we are part of the Fast Track program as well. So it's a solution-based ecosystem that we want to bring to the Windows Server 2012 environments, and we want to provide the most optimal infrastructure for Windows Server workloads. So coming to the virtual networking solutions again, we are bringing 2 different solutions to the Hyper-V environment. One is a software-based solution. There's a Cisco Nexus 1000V. And the other one is a hardware-based solution. That's the VMFX, the Virtual Machine Fabric Extender. One is a pure software solution. It brings advanced feature set and the networking all the way into the hypervisor. And it brings, along with that, integrated services, networking services. And the other one, that's the VMFX, is a hardware-based solution. It brings the virtual networking all the way to the network interface card, and it brings bare metal performance all the way to the VMs. So you can bring the 10 gig performance all the way to the VMs. So on one side, you have a flexibility, advanced feature set, integrated services. On the other hand, if you want performance, you need to go for VMFX. So with that, I want to move into the Nexus 1000V. And over the next, hopefully, 15 minutes, I'll cover the Nexus 1000V architecture, and then Chakri will take over. Before I jump onto the architecture, I want to briefly talk about the public beta. We announced the public beta for Nexus 1000V about a month back, and please do participate in the public beta. We have a large number of customers that are already enrolled, and it's fairly easy to participate. All you need to do is send an email to beta-n1kv@cisco.com, and you'll receive an invitation. And we have a lot of documentation, latest bits available for you, and please do participate in our beta. And I want to mention one other thing. We made some recent pricing changes for our Nexus 1000V platform. This is in October 2012. We introduced tiered pricing for Nexus 1000V. So if this tiered pricing, we have two editions, an Essential Edition and an Advanced Edition. So the Essential Edition has most of the functionality that you would expect in an access switch, L2 switching, the manageability, SNMP, network monitoring capabilities, and the strong integration with the management ecosystem or the virtualized environments. And it's free. And you can buy tax support for this at a nominal price. And if you want more advanced security for your virtual environments, then you want to go for the Advanced Edition, which is $695 per CPU. And the Advanced Edition includes multiple additional security features like dynamic ARP inspection, DHCP snooping, and IP source guard. And in addition, we also can make use of the virtual security gateway. So just want to mention that. And jumping into the architecture, I have a couple of slides that talk about a very high-level overview of the Nexus 1000V architecture. For those of you who are not familiar with the 1000V, this should be a good primer. I just want to check, how many of you heard about the Nexus 1000V? All of you, most of, okay. How many of you currently have Nexus 1000V in deployment in your data centers? Okay, very few of you, okay. So hopefully this presentation will help you make the decision. So if you look at the 1000V, we leverage the Hyper-V extensible switch framework that Microsoft introduced with the Windows Server 2012 architecture. In the Hyper-V extensible switch architecture, Microsoft allows ISVs, or the integrated, the ISVs, the software vendors, to develop extensions to extend the capabilities of the native switch. So they allow you to have forwarding extension, a capture extension, and a filter extension. Nexus 1000V sits, one component of the Nexus 1000V, we call it a VEM, or the Virtual Ethernet Module, sits inside this forwarding extension in the extensible switch. Even though it sits as a forwarding extension in the extensible switch, it also offers both the capturing capabilities as well as the filtering capabilities. So if you have Nexus 1000V, you don't need either the capturing extension or the filtering extension. And another component of the Nexus 1000V, we call it a VSM, or the Virtual Supervisor Module. This is a VM that can run on any Hyper-V host, and one VSM can manage multiple VEMs. So this VEM on the left-hand side is deployed on each and every Hyper-V host, whereas the VSM is deployed on one host, and it can manage multiple hosts. And the VSM is tightly integrated with SCVMM, and it communicates, it propagates information back and forth between the SCVMM and the Nexus 1000V. So the VMs, when you instantiate a VM and you want connectivity to that VM, you do that through a virtual Ethernet port construct. And those virtual Ethernet ports are sitting right on the Nexus 1000V VM. So what do we bring to the Hyper-V infrastructure? We bring 4 things. We bring the goodness of the NXOS architecture, the reliability, high availability, and the advanced feature set to the Hyper-V environments. Whatever you can do on any of the physical switches, you can do that on the virtual switch for Hyper-V. And we bring the innovative services architecture. I have a couple of slides that kind of detail the information about vPath, but we bring this services architecture which allows us to extend the platform to include multiple networking services. And then we provide consistent operational model. The way you currently use your physical infrastructure, you don't need to change the operational processes, you don't need to change the management tools, you don't need to change the monitoring tools, you don't need to change the troubleshooting tools. Whatever tools you currently use, processes you currently use for your physical environment, you can use the same tools for your virtual switches as well. Very powerful advantage. And then we have tighter integration with SCVMM, as well as the Windows Server 2012. Here I want to thank the Windows Server 2012 team, as well as the System Center 2012 team for their collaboration. We've been working with them for the past 2 years, and I want to thank them. So here is another way to define or to describe the architecture of Nexus 1000V. If you are familiar with any of the physical switches, or any Cisco physical switch has 2 important components, a bunch of supervisor modules and a bunch of line cards. And here we are keeping the same consistent architecture. We created a VM out of the supervisor module, and we call it VSM. And we moved the line card logic all the way into the Hyper-V, and we call it a VEM, or the Virtual Ethernet module. So so this entire thing on the right-hand side forms the virtual distributed, the Cisco Nexus 1000V distributed switch. So it's a very highly distributed architecture. So again, another way to see a simple deployment of Nexus 1000V. You have multiple servers here, 3 servers, all of them connected to the physical network using Phoenix, and each of them running Windows Server 2012. And the 2 components of the Nexus 1000V, the VEM is deployed on each and every host, and the VSM, or the management module, is deployed as a VM on a Hyper-V host. And your SCVMM communicates with the VSM. So that's the typical deployment model associated with the Nexus 1000V switch. Again, I want to briefly talk about the features. There's a laundry list of features. One way to describe the features is whatever you can expect from a physical access switch from Cisco is available in Nexus 1000V. So from all the advanced switching functionalities, VLANs, PVLANs, QoS, all of that is available. From a security perspective, port security, ACLs are available. And in addition, we have the dynamic ARP inspection, IP source card, DHCP snooping, etc. And again, like I mentioned earlier, we are building a very strong services ecosystem around Nexus 1000V using vPath architecture. Again, from a provisioning perspective, we came up with a concept called port profile. This is about 5 years back, and that's available on the Hyper-V as well. And the tight integration between SCVMM and the Nexus 1000V really simplifies the overall provisioning for your virtual machine networking. Visibility, again, whatever visibility tools, whatever monitoring tools, whatever performance monitoring tools that you currently have can be used for watching Nexus 1000V as well, because it exposes the same features that are available on your physical switches. NetFlow, SPAN, ER SPAN, all of them are available on Nexus 1000V. Management, again, the same management interfaces that you would expect in a physical switch. The same NXOS CLI, Radius TACACS integration, syslog messages, SNMP, all of these are exactly the same across both physical switches as well as Nexus 1000V. So your existing network management tools, network monitoring tools, troubleshooting tools can be used across both Nexus 1000V, across physical and virtual environments. I want to briefly talk about the port profile concept that we introduced about 4 years back. And port profiles is a way to templatize your network policies. It's a way to proactively come up with configuration information in advance so that when you want to deploy a VM, you can just pick and choose that particular policy and instantiate the policy right away. So for example, in this, here, in the slide here, the admin, network admin, realized that there are only 4 types of applications. He has web applications, HR applications, database applications, and DMZ applications. Then he can create, he knows that all the web servers have a specific type of ACLs that need to be applied, security policies. If he knows that all the web servers need specific bandwidth, has specific bandwidth requirements and specific monitoring requirements, he can templatize all of that, define that well in advance, and publish that right into the SCVMM so that the SCVMM administrator, whenever he wants to instantiate a web server, all he needs to do is just pick that particular port profile. So it's a proactive way to define your network policies. And one good thing about this port profile concept is when you want to change something, let's say you want to add an additional set of ACLs to your web servers, you don't need to go to all the 200 web servers that are using this port profile. You can just use the web apps port profile and add the ACLs, and automatically that information is pushed out to all the servers that are running this particular policy. So pretty powerful concept. So the other good thing about port profiles is that once you instantiate a VM with a specific port profile information, that policy sticks with the VM throughout the life of the VM. No matter where the VM moves, from one rack to another rack, one pod to another pod, it doesn't really matter. The policy sticks with the VM. So this is what we introduced about 4 years back with Nexus 1000V, and all of this is available for the Nexus 1000V for Hyper-V. Moving on, so over the next, I think 6 or 7 slides, I want to briefly talk about the new concepts that the System Center Virtual Machine Manager introduced in the 2008 R2 as well as in 2012 SP1. If you look at the top 2, logical networks and network sites, I'm sure most of you are familiar with all of these concepts, but just want to briefly talk about them. If logical networks and network sites, I think, were introduced in 2008 R2, and we have provisions to create them in the Nexus 1000V. And the 2012 SP1 introduced multiple new concepts, including VM networks, port classifications, and IP pools. I have a slide for each of these things. I won't spend too much time here. But a logical network represents a network with a specific connectivity characteristic. These connectivity abstractions can come from your business needs or the way you want to isolate your workloads, etc. And an instantiation of this logical network, this abstract entity called logical networks, onto a set of host groups onto a set of physical infrastructure, networking infrastructure, using VLANs is called a network site. So for example, you have 6 servers in this specific case here, 4 servers in San Jose and 2 servers in Seattle. You can create a logical network that can span across both the entities, San Jose and Seattle. And you can instantiate different network sites, 3 network sites for physical isolation of traffic across these hosts. So this was introduced in 2008 R2. I think this was extended in 2012 SP1 with the introduction of the virtual machine networks or the VM networks. The idea is the VM networks can either leverage the physical VLANs that you currently use, or they can use some of the overlay techniques like NVGRE. So just want to briefly talk about that. And then they also introduced this concept of port classifications. Given that this extensible switch can have multiple extensions, forwarding, capturing, and filtering extensions, each one of them can have its own port profile or profile. And a bundle of these port profiles is called a port classification. So in the case of Nexus 1000V, given that it does both the forwarding, actually all the three extensions together, it does forwarding, it does capturing, it does filtering. So it's the same as the port profile concept in Nexus 1000V. You can define these port classifications in advance, and they can be used in the they can be used whenever you instantiate a VM. So again, this might be this is a question that a lot of our customers were asking us in terms of what do you really need if I want to connect a VM, when I create a VM, what are the things that I need to connect it to a virtual network? So in SCVMM, you have three constructs that you need. You need to specify the VM network that VM should be part of, and then you need to specify whether it should have a dynamic IP, whether the IP address is coming from a DHCP server or from a static IP pool, and then you need to specify the port classification, the kind of access policies that you want, the kind of monitoring policies that you want for the particular VM. So these are the three concepts that you need in advance when you want to create a VM. So just one slide just to showing how all of this fits together. So you can have a logical network called DMZ, and your DMZ can be in San Jose, Seattle, but all of that, all the network characteristics remain the same, right? So you can create that, and then within that, for your San Jose site, you can create a network site called DMZ Pod 1, and for Seattle, you can create DMZ Pod 2. And then within each of these network sites, you can create VM networks, depending upon the access characteristics of the VMs that use that particular DMZ pod. And you can associate specific IP pools for each of these VM networks. And of course, you can then, whenever you instantiate a VM, you can associate that VM with a specific VM network, and then associate a specific policy, access policy with that particular VM. So that's the these are the different concepts that were introduced in 2008 R2 as well as 2012 SP1. So what does this really mean for the Nexus 1000V? We tweaked some of our existing concepts in Nexus 1000V to fit the SCVMM terminology or the SCVMM concepts. For logical networks, both the terminology is the same across both Nexus 1000V and SCVMM. For network sites, we came up with a concept called network segment pools, a way of pooling multiple network segments together. And the VM networks is the same as network segments. We created a concept called network segments within Nexus 1000V, and that is the same as VM networks. And IP pools are the same across both SCVMM and Nexus 1000V, and port classifications are the same as port profiles with the Nexus 1000V. So just a slide providing an overview of the mapping between the different constructs in SCVMM and Nexus 1000V. For an example describing how you can create the DMZ example that I outlined a few minutes back. So for creating a logical network called DMZ, all you need to do is just apply this CLI, logical network DMZ. And to create a network site, you do a network segment pool DMZ pod 1. And for creating each of the VM networks, you just create network segment and then followed by the name of the VM network. And then you can associate specific IP pools for that particular VM network. So that's the overview of the different concepts. I want to briefly talk about the difference between the network segments and the port profiles. This is a question that comes up quite often with our customers, so I just want to briefly talk about it. So the port profiles are more like access policies, whereas the network segments are more for connectivity of the VMs to a particular network. So for example, in this particular example here, you have intranet, and you can have this intranet network being used by multiple types of VMs. You can have client VMs, and you can have guest VMs, and you can have application server VMs. And even within each client VM, you can have privileged users, you can have normal users, and things like that. So for defining the access policies associated with each of these VMs, you create port profiles. And this is quite different from the network segment. So here you have one network with multiple port profiles for defining the access policies. And once you define these access policies, these policies can be utilized by multiple network segments. For example, here, there are multiple tenants here, all of them trying to create their own intranet. But the type of VMs, the type of access policies can be the same across these three different tenants. So you don't need to recreate port profiles for each of these networks. So that's the overview. Just I want to mention that, given that a lot of our customers were asking about this separation between the network segment and the port profiles. Another example on how to define port profiles, especially how we define it in the existing product. That's the Nexus 1000 for vSphere versus the Nexus 1000 for Hyper-V. So if you have an application network, a VM network called app network, and then you have client VMs accessing that network, and you have application servers accessing the same network, but with different access policies. And in the Nexus 1000 for VMware vSphere, you actually define port profiles called application client and internet server. And these port profiles include both the network attributes as well as the policy attributes. For example, here you have an access group associated with each of these port profiles, and you have a network attribute associated with each. Whereas in the case of Nexus 1000 for Hyper-V, you separate out the network attributes from the access policy. You create port profiles that doesn't have any network attribute information, but you create a separate network segment to refer to the specific network connectivity abstraction. So just that's the difference. And I just want to provide an overview of the operational model associated with the Nexus 1000 for Hyper-V. So the network admin logs into the Nexus 1000 VSM just like you would do on any physical switch, and it creates the networks, segments, network sites, and logical networks using the NXOS CLI. And these policies and networks are automatically propagated to the SCVMM. And when the SCVMM admin wants to create a VM or wants to add a host to N1KV, he can use these abstractions, these definitions provided by the network admin, and SCVMM uses them to instantiate those VMs on the specific host. And the VSM, once the VMs are created on a specific host, the VSM pushes the configuration policy to that particular VM. So that's the overall operational model. I want to briefly talk about a couple of additional things that we added to the Nexus 1000 for Hyper-V. Some of our alpha customers, I think Tom and Adam are right here, Globe University. So they were asking for a way to automate some of the provisioning associated with Nexus 1000V. So we added this REST API support, where if you can identify the specific objects that you want to modify in Nexus 1000V, you can create a URI, or the Universal Resource Identifier, associated with that particular object. You can create that URI and then pass it on. You can pass a couple of arguments associated with that particular URI and then send it out to the VSM. VSM sends you back the results in an XML format. And you can parse the XML to make the decisions that you want. So this is the REST API support that we provided. And you have access to multiple objects in VSM, including, for example, IP pools. You want to create an IP pool, you want to update an IP pool, you want to delete an IP pool. All of that can be done through PowerShell, through REST APIs. All the CRUD operations are supported on some of the objects. So PowerShell 3.0 has some specific constructs to directly invoke REST methods. It has something called invoke REST method, and you can use that to directly use the REST APIs. Here, for example, you just create some of the credentials. You create the basic parameters required for API calls, including the VSM, IP address, the username, password, etc. And then if you want to add a new IP pool, all you need to do is just create an argument string with the specific arguments that you want. For example, here you want to say that I want to have an IP pool with address range starting from 192.168.0.2 to 16. You can create that and then convert that string to JSON format and then just pass it, call the invoke REST method. And you can do that with, you can do update objects, you can do read objects, you can do delete objects using this PowerShell interface. So also want to mention that we have this, one of our partners, Jalasoft, has created this COM plugin that can support Nexus 1000V. So using this COM plugin, you should be able to monitor multiple devices using, multiple parameters on the Nexus 1000V as well as some of the Nexus switches. So again, coming to the operational benefits, we provide consistency is our main important benefit. We provide consistent networking features across physical, virtual, and across hypervisors. And we provide consistent operational model. Whatever operational processes you have, whatever operational tools, monitoring tools, management tools, troubleshooting tools, they are applicable. The same tools can be used across physical and virtual environments and across hypervisors. And we provide consistent network services across physical and multiple hypervisors. And I want to briefly talk about the vPath architecture. Like I mentioned earlier, this services architecture really helps us to extend the overall platform to include multiple network services, including firewalls, monitoring devices, WAN application acceleration devices. And this vPath is a component that sits right inside the WEM module that is inside the Hyper-V extensible switch. So when vPath intercepts a packet, it knows this vPath component is multi-tenant aware, and it also services aware. It knows that this particular packet needs to be serviced, needs to be sent to a particular firewall. So then it sends it to a VM, we call it a VSN or the virtual service node, and this VSN can be sitting on any host. So vPath knows exactly that this particular tenant has a firewall sitting on this particular host, and it sends a packet to that firewall. And this firewall does all the computational magic and decides that this particular packet needs to be allowed and sends that decision back to vPath. And vPath caches the decision and then enforces the decision locally on that particular host. So there's a separation of enforcement and policy decision making. So it's really efficient, especially for private cloud environments. And vPath, given that it knows it already cached the decision, it next time it sees a packet from the same flow, it doesn't send it back to the firewall. It enforces that decision locally. So we are introducing the virtual security gateway to utilize this architecture initially, and we want to bring a whole lot of other services to use this particular architecture going forward. So I want to briefly talk about the beta. Like I mentioned earlier, this particular product is available for beta. We announced it in March. We have a large set of customers that are already participating in the beta. Please do participate, and it's very easy to participate in the beta. Anybody with a valid email ID and can participate. All you need to do is send an email to beta-n1kv-hyper-v@cisco.com. And we have a whole set of documentation and videos on how to install, how to define, how to configure different features with respect to Nexus 1000V. Please do look at these documents and please do provide us some feedback. And we have a nice installer tool that really simplifies the overall deployment experience with respect to Nexus 1000V. Once you install this installer tool, it takes you a couple of minutes to install VSM and VEMS. All you need is the SCVMM, username and password, and the specific host that should host the VSMs, with both the primary and the secondary VSMs. And that's pretty much it. Within a few minutes, you should be able to deploy the Nexus 1000V on in your data center. So I have a video outlining some of these features. Give me 1 minute to switch here. Any questions so far? Please.
So your VSMs are on two separate VMs? Is your primary VSM and your secondary, you run those on two separate VMs or on one VM?
There are two separate VMs, yes. Typically, we ask customers to run the primary VSM on a separate host from the secondary VSM for availability, high availability.
Any other questions?
So here we have the demo topology is pretty simple. It's a very simple use case. We have two servers running Windows Server 2012, and one server has an employee VM and a contractor VM, and the other server has a web server VM. And the idea is to restrict the access for the for the contractor VM to access this particular web server. And so you configure the port profiles in such a way that the employee VM can access the server, web server, but the contractor VM cannot. And then the next part of the demo is to monitor this VM to VM traffic using the network, the analysis module, or the NAM. Let me switch to the, sorry, give me 1 minute here. So this is how, this is the topology. On the left-hand side, as you can see, we have a cluster called cluster SJC that has two hosts, HV6 and HV7. And this entire cluster has 3 VMs, an employee VM, a server VM, and a contractor VM. And the HV7 hosts web server, and HV6 hosts the employee and the contractor VMs. So you can actually, so you can actually look at the connectivity associated with each of these VMs by clicking on the host and then view networking. As you can see here, contractor VM and the employee VM are connected to the Nexus 1000V switch. And all this from the System Center Virtual Machine Manager. Right? You can have a good overview of what's happening in your network just directly from SCVMM. And you can get a lot more information by just clicking on the fabric ribbon and look at the switch extension managers. As you can see, you have the Nexus 1000V plugin embedded right into the client here, and you can get a lot more information by clicking on the properties. You can look at what are the hosts associated with this particular logical switch, or all the information related to this particular extension, and the different version information, etc. If you click on the host groups, as you can see here, it's applied for all the hosts. Right now, there are only 2 hosts, HV6 and HV7. So all of them, they use the same logical switch. That's the Nexus 1000V. And here, if you click on the port classifications, you can see that there's a library of 2 port profiles, an access port profile that allows the employee to access the next web server, and a deny port profile that restricts the contractor VM to access the web server. So if you go to the VSM, you can utilize the NXO CLI to exactly get an overview of what's happening in your virtual environment. You can just look at what are all the hosts that are connected with my Nexus 1000V by typing show module, and you can see that there's 1 supervisor module, 1 VSM in module 1, and there are 2 other hosts that are connected to this particular switch. That is the module 3 and module 4, or the HV6 and HV7. And you can get a lot more information about all the VMs that are connected with this particular Nexus 1000V switch by typing show interface virtual. Give me. So you can get, I mean, this is from the network administrator perspective. Using NXOS CLI, you should be able to have the same information that you would if you are looking from a SCVMM perspective. So for example, here you can see that there are 3 VMs. Employee VM is using a port called VETH1, contactor VM VETH2, and the server VM VETH3. And you can look at the port profiles associated with each of these ports by typing show running configuration. And here we have the employee VM has just a VLAN 20 and there are no other access policies, whereas the contactor VM has multiple access policies defined on both the incoming as well as the outgoing traffic. There are two access group called deny blue client for both the incoming as well as the outgoing traffic.
No, you're good.
So you can actually look at.
We have enough time. Okay.
So you can actually look at the access list rules. So that deny blue client has multiple rules, but the rule number 50 says that deny all the traffic on the www port. And you can find out the same, whether these particular port profiles are doing what they should, by going to each of these VMs, the employee VM and the contactor VM, and try accessing the web server. So the blue badge employee, when he tries accessing the web server, he can access the web server. Whereas the contactor, the red badged employee, when he tries accessing the same web server, because the port profile says that all the incoming traffic and the outgoing traffic should look for the traffic on the web server port and drop it, so he cannot access the web server. So you can define these, I mean, this is a very simple example, but you can define a lot more complicated access control lists for your traffic using the Nexus 1000B. Right, all from a central location, you got to log into BSM using the standard ACLs that you typically use on any access switch from Cisco. You can define the same set of ACLs, and those are automatically pushed to each of these VMs, and you can apply all the advanced security policies. In addition to the security policies, you can also use the monitoring tools to see what's happening on your network. We have a monitoring tool called NAM, or the Network Analysis Module. Give me 1 minute here. So we have a tool called Network Analysis Module that allows you to analyze traffic, whether it be physical or virtual, and you can slice and dice your traffic on multiple parameters. You want to find out who are the top talkers in my network. You can do all that by using NAM. So in this case, we are actually using ER span to push all the traffic onto the for the client and the server VMs onto NAM, and you can see what's happening in the virtual networking. Right, so you can identify all the top applications that are eating up your bandwidth, the top application groups, or the top hosts, and what protocols are taking up all your bandwidth and things like that. You can actually have a better visibility into what's happening into your VM-to-VM networking traffic using NAM. This is just one service example. We have a lot of other services coming up on Hyper-V. Specifically, we are planning to introduce the VSG for Hyper-V along with the Nexus 1000V. So that's pretty much it on my end. Now I want to
any questions
give it back
at this
to
point?
1000B. Even if you come up with questions later on in the next few minutes, please feel free to stop us and ask for questions.
Please go ahead.
One second. Okay, you repeat the question. Maybe action.
So what does this look like from a physical standpoint? Right? You know, so I've got a 1000B. Do I have 1000B on every physical host, or is it more less granular?
So the question is, how does it look from, how does the Nexus 1000V looks from a physical network perspective?
No, physical standpoint. So
So Nexus 1000V is a software switch, right? And it has two components, WEM and the VSM. And
I get the VSM part.
right, you're talking about the WEM. How does it look?
The VEM, yeah. So where does the VEM go? Does it live on every physical host?
Right. It's embedded into the Hyper-V extensible switch as a forwarding extension. So on every physical host that's managed by the Nexus 1000V has the WEM embedded.
And then every virtual machine has Microsoft VNIC, or is there a Cisco VNIC?
It is the Cisco VNIC.
Okay.
So the WEM manages all, the VSM is where you define the networking configuration associated with each of these VNICs. And whatever you define in VSM is automatically pushed to the SCVMM so that the information is consistent across both SCVMM and VSM.
So would all the interfaces in your server basically be trunked back to your core and then just push all the VLANs out through the trunk? And then at that point it would do all the crazy amount of VLANs for the virtual boards?
Can you use the mic, please? And can you repeat the question?
Well, so on all your physical NICs on the server, would you just trunk those back to your core and just push all the VLANs out to that through that trunk and then do your VLAN, pushing out the VLANs to the virtual ports?
That's correct. So yeah.
So it's actually got intelligence, it's not like a fabric extender then. So you don't have to have a 5000 for this to work. It's an actual intelligence switch. It's not just a fabric extender.
Right. It's an intelligent switch. So the forwarding decisions are made right inside WEM. So it has all the intelligence built in, and it gets the configuration information from the VSM. So VSM is the management point. Once you define these policies, they're automatically pushed down to the VEMs.
As an example, if you had a single VSM, once everything was set up and we didn't need to make any changes, I've actually gone in on mine and had ping flows going on and shut my VSM down, and all the flows kept working. The flow don't have to go through like the VSM. They're just getting the policy from that, and then has kind of its own localized intelligence for switching.
Any other questions, please?
Question.
So does this
Sorry.
take over the physical plant, meaning my physical host has 4 connections into my core, right?
Right. Okay.
This will override and take care of that? In other words, it'll take care of the networking between my physical core and the VSM? Or I'm going to have to configure the connectivity into the core as well?
I actually didn't understand the question, so maybe can you?
Physical host has 4 connections, right?
Your physical workloads, yes.
I'm going 2 connections to one switch, 2 connections to another. That's into my core. Does the VSM take that configuration over, or is it?
So VSM is primarily for virtual workloads.
Yeah.
Joseph, do you have?
Nexus 1000 WEM will take over the 4 NICs, so that any traffic from the VM to the upstream switch will go through the WEM first, then hit the physical NIC.
Any other? All right, thanks, Appaji. My name is Chakri. I'm the product manager on the UCS side. Like Appaji mentioned, Cisco is introducing two solutions, one on the software side, one on the hardware side. So in the next few minutes, I'm going to talk about Cisco's hardware technology, VMFX, virtual machine fabric extender technology that we'll be introducing. And we'll be talking close to another 20 minutes. So how are you guys doing so far? Good? Excellent. Okay. 20 minutes, so I'll be talking as less as possible and try to give more information through the demos. That is my idea of exchanging the information with my audience. So in Windows Server 2012 Hyper-V, virtual workloads for the customers who demand that uncompromising performance, but coupled with the manageability and the consistency that Appaji is talking about. Cisco is working with Hyper-V in Windows Server 2012 and bringing the same exact concepts that Appaji talked about so far into the hardware land. By doing that, the administrators in the data center will be able to provision, monitor, configure, manage both physical and virtual networks in a consistent way. Let's take a step back, and how many of you actually are deploying? I'm not going to ask how many of you know UCS because the question was asked before, and close to 60% of you are using UCS. How many of you are deploying private cloud on UCS? That's a pretty good number, right? And one of the challenges when I talk to customers about the private cloud deployment is trying to manage both your physical and virtual environments in the same way. So, for example, why that is important? Does cloud deployment means you have to have the environment virtualized? Yes or no? The answer is definitely not. Your cloud has nothing to do with virtualization. That's number one rule. In the sense, let me ask you this question. When you use, this is one of the good examples we can talk about. Google, you all use Gmail, use Yahoo Mail. Can you say for sure it is virtualized in the back end? As a user, when you look at it, can you tell whether it is virtualized environment or bare metal that is running the Google server, your service? Does anybody have an answer to that?
Yeah, who cares?
That's the answer, right? The same way, when I look at from other side of the table, when I look at it as an admin, when I get the request from a self-service portal, I don't care whether it is for a physical resource or a virtual resource. My management policies, my network policies, my security policies has to transcend from physical to virtual seamlessly. I don't have to one set of policies for virtual, one set of policies for physical, be it a compute, be it network. We nailed that in Cisco UCS on the compute side. So how can you do that on the virtual side? Nexus 1000V will offer that flexibility on the network side. Let's see how we can do that on the physical side. By combining the Cisco UCS Fabric Interconnect, network technologies, and the management technologies with Wake virtual interface card, we are bringing this technology to our customers so that by extending the Fabric Interconnect all the way to the VM, now VM has a direct access to the physical network. Each VM gets its own physical port at the switch. By doing that, VM's traffic hits the port, the physical port. That way, you're collapsing both physical and virtual networks to the same physical infrastructure. And every policies, every monitoring tools that you're using, anything that you have deployed before works seamlessly across whether it is a virtual network or it's a physical network. You are doing exactly the same. Plus, you're reaping the benefits of having the wire speed performance given to each VM. So for those virtual workloads that demand that performance, you can achieve that performance through the VMFX technology, right? And VMFX also, let's talk about the management side of it. When I said the management has to be consistent across physical and virtual, you are familiar with the UCS Manager, right? How many of you use UCS Manager today in Cisco UCS? Excellent. So UCS Manager, if you're familiar with UCS Manager, it's all policy-driven management, right? Do it once and forget and let it manage. Maybe it one server, two servers, hundreds of servers. Maybe it one VM, 10 VMs, hundreds of VMs in a given domain. Be consistent and simplify for the admins. VMFX management is coupled tightly integrated into the UCS Manager. So you get the same exact benefits of managing and deploying VMFX across your entire environment. We also bring the benefit of the separation of let network admins do their job and server admins do their job. In the sense, what I mean by that, because virtual world blurs this line between network and compute. So how can we make everybody's life easy? In the UCS Manager, the port profiles that we talked about before, the same concept carries over to the UCS Manager. The port profiles are the same, whether it's a bare metal or it's a VM. The port profiles are the same. Let network admins define those and give them to the server admins so that they can consume it instead of worrying about what the network profile should look like, what it is, what the QoS policy. Those are all defined by the network admins, consumed by the server admins. Right? Now let's take a look at the performance. One of the big questions between when we talked about the cloud, right, physical versus virtual, the big question or where the issue comes up is for a physical resources, you can always walk into a data center and say, where is my SQL? You can point to a server and say, that's my SQL. It's static, it runs on it, you know what the policies are, what the security policies are, what the performance is, and you know that. What happens when it is virtualized? What are the challenges as an admin from the customer point of view when you look at it? The challenges that you face are twofold. Number one, the performance. You need to guarantee the performance when it is a VM, right? And why is that important? Because the VM can move, whereas the physical, when it is attached to a physical server as an application, it's not moving anywhere. Today you leave it here, tomorrow come back, it's still there. VM, no. You can live migrate from point A to point B. So how can I guarantee that performance across, irrespective of where my VM is? And with Cisco, with VMFX technology, my policies, the network policy and the security policy is persistent. What I mean by that is they live and die with the VM. Throughout the VM life cycle, wherever the VM is, the policy moves, thereby guaranteeing that performance across wherever that VM lives. And in 2012, there is also a new technology that Apache talked about, switch extensions, right? What does that allow you? That allows you to bypass the hypervisor. And with VMFX, the VMs now have direct access to the physical network, bypassing the hypervisor through Cisco-provided switch extension that goes directly into the Hyper-V. And let's see how that is done in the next couple of slides. So far, okay? Right. VMFX has two modes of operation. One, the standard mode, or we call it enumerated mode, or the hypervisor bypass. That is the turbo mode, I call it. That is the high performance mode. In both modes, number one of the things that I would like to emphasize is live migration is supported in both the nodes and in both modes. And in both modes, you get the benefits of Cisco UCS management, policy-driven, consistent management policies across both modes, irrespective of which mode you use. Right? What happens in the hypervisor bypass mode, you get all the benefits plus the improvement in the I/O performance, because now the software switching that happens in the hypervisor, that is eliminated. VM goes directly to the switch, and all the switching happens at the physical layer in the fabric interconnect. It's all offloaded to fabric interconnect, and you get the direct 10 gig performance all the way to the VM. And By saying that, I'm also saying all the VIC cards, Cisco VIC cards, are SRIOV capable. They have to be SRIOV capable before, for us to say that it's a hypervisor bypass capable. Any questions? So let's see how the live migration happens with the hypervisor bypass, because it is a unique feature of Cisco. None of the other adapter vendors can do that. Live migration with hypervisor bypass, both on the same adapter, on the same hardware, right? Let's say, for example, let's take a VM running on a host, on a hypervisor in the hypervisor bypass mode. And when live migration kicks in, VM changes its I/O to bypass mode 2 to the enumeration mode, by which it is using the switch that is built into the hypervisor. I/O goes through that and it requires the I/O. Move VM over to the other host and bring up the I/O in the standard mode. Then, once I/O connection is established, just switch it over to the bypass mode. Seamless, easy, and it's transparent with very little to no latency when the I/O switching from the standard to enumeration mode happens. Actually, I should have mentioned this before. What Apache talked about the very second slide, I hate to repeat that. This is all coming. We are still cooking in the lab, in the engineering. So we're giving you the sneak preview into what's coming on the hardware side, right? So you're aware of that. These are forward-looking statements, so to speak. So what is coming with SCVMM? You're all familiar with the SCVM 2012 that came out a year ago, and then the SP1 came out. Actually, the slide should have said SCVMM SP1 because it's more relevant to the SP1, what I'm talking about. SP1 is where the management of Hyper-V was introduced into SP1. With VMFX, Cisco will be providing a package of the bits. When you install the bits, two things will happen. So we're going to talk about two things here. One, let me figure out how I can, good, okay. The two paths here, just focus on these two. So the two things that need to happen is we need to make a connection at the management level. How do I manage all my policies, port profiles, QoS policies defined on the UCS manager given to SCVMM? That's number one, so that SCVM can manage these VMs. The second is the data path. Because we are bypassing the hypervisor, I need to provide the data path from the VM into the fabric interconnect. That's the second one. So we're going to hit these 2 points, or these two, through the provider DLL we're providing. So the package installs two things. One, the provider plugin into SCVMM to take care of the management side of things. And we're also will be providing a template of this extension into SCVMM so that every time SCVMM brings up an Hyper-V host, it actually knows what extension to provide to the Hyper-V host. So thereby offloading, imagine you as an admin with a fully populated UCS domain of 160 blades, roughly give or take 30 to 40 VMs running on them. So you're looking well north of maybe 5,000, 6,000 VMs. I don't want to be in your shoes if I'm going to manage that environment. And if you're trying to manage the policies and be able to define the live migration and say guarantee that consistency and the performance for these VMs, you have to offload this big management stuff to somebody who can deal with these VMs at a large scale. And that's what happens when we do this. We define all the policies here, give it to SCVMM, and tell SCVMM, you deal with the Hyper-V host and the VMs as you bring, throughout the life cycle of the VM. Right. So far, simple? Any questions? Okay, moving on. And these are just the screenshots we provided, but my subject matter expert, Timothy Ma, technical engineer, he will be doing the demo, and you will see how these things happen. Actually, we will be running through each step of configuring this stuff, right? This is an eye chart, okay? So I apologize. And actually, some of the concepts, Apache actually made my life easy by covering most of these concepts, so I'm not going to talk about these things, distributed virtual switches and the domains and things like that. All the thing that I want to point out here is one simple thing. That is, today, the question comes up, what is our support for live migration? How far can we migrate it? So today, it is limited to, or in the first release of when we go out with the GA, the live migration is limited to the one UCS domain. In the sense, VMs can move onto any host within one UCS domain, but in subsequent releases, we will extend that to multiple UCS domains. We'll be going into the demo, so maybe at this point, I'll hand over to Timothy to walk you through each one of these steps. And that should take maybe another 7 to 8 minutes, and then we'll have some time left for Q&A. Yeah, you're good.
Okay, so good afternoon, everyone. So we prepared a demo just to showcase the process of how UCSM Manager and SCVM integrate together. And then we're just going to go through the video really quick. I know we're running late for time, and thank you for your patience. Okay. So, sorry. So for folks who are familiar with the UCSM interface, we're going to start with the under the VM tab. So I already pre-provisioned some of the SCVM components that's required to do the integrations. So if you look at first underneath the fabric network, you will see a logical network called Blizzard. So this is like act as a logical container that contains multiple fabric sites. In this configuration, we have two multiple sites available here. One is the Blizzard-SF, and the other one is Blizzard-SJ. And within each logical site, we also have several logical segments that's defined. For each logical segment, what we have is we have a specific VLAN as well as the IP pool associated to a logical segment. And those logical segments are used when you provision the VM. You need to attach the VM to the VM network. And in SVMM, when we provide those logical segments, it will translate to the VM network. So when your VM is provisioning, it automatically get the VLAN information and also the IP as well. And next, that's where the VM network. The VM network is used in the SVMM, and in the UCSM Manager, we have a one-to-one match between the VM network and the logical segment. As you can see, for example, on the very top line item, we have a lab-dev-net. That's a VM network. Will be later on be fetched into the SCVM. It matched to the corresponding logical network and also the network segment. And that's how your IP and the VLAN information is getting passed down from the UCS Manager through the VM network and then through your VM when you provision the virtual machine. Next, we also need to define the SCVMM instance within the UCS Manager. Here, we only show one SCVMM instance, but we understand there's situation, for example, you have SCVMM cluster, or you have multiple SCVMM instance existing in your network. So we do support up to 4 SCVMM within the UCS Manager. So in this particular area, you can actually create 4 different instances, and it all have different logical network attached to it. With each SVMN instance, we can also define a logical network. This logical network will be basically equipped with the Cisco forwarding extension that Apache and Chocolate has mentioned about that will enable the hypervisor feature to achieve the higher performance for your virtual machine traffic. And will be configured directly from the UCS Manager and will be fetched to the SVMN for the later use. And within each logical switch, you will also have different uplink profile, as you can see underneath here. We have 2 uplink profile defined, which will characterize different physical uplinks that connect to your logical switches. Okay? And lastly, in the UCSM manager, SVN also introduced another concept of virtual profile. We talk about uplink profile, that's the profile characterize your uplink switch, uplink to the switch, but we also have a virtual profile that including the QoS policy and the network control policy that's characterize your virtual machine interfaces. So how do you apply your QoS setting to your individual virtual machine traffic, and will be associated through this virtual profile.
Virtual port profile that moves along with the VM, irrespective of where the VM lives. Could be host 1 today and host 10 tomorrow, so that you have the same QoS policy that going along with the VM.
Okay, thank you. So now we have provisioned the basic network infrastructure from the UCSM side, and we're going to start the integrations. So the first step in integration is actually very straightforward. We have the installer provided. We can directly install on the SVN host, the host that hosts the SVN. Once the installer is complete, we can go to setting, and underneath the configuration provider, you will see an additional line called Cisco UCSM provider. So this is actually the provider plugin that continues query the UCSM manager and fetch all the data you configure from the UCSM. So that's the reason when the network admin, when they add additional logical switch in the UCS manager, this particular provider will do a periodic query, and they will see there's a new component of logical switch, and then they will get fetched into the SCVMM. So the server admin will be able to use this additional logical switch. And this applies to also to the uplink profile and the virtual profile. Anything we configure from the UCM side will be fetched through this provider into the SCVMM domain. And it will also show you the status and also the corresponding UCSM version. This is currently not available, but will be available, but we expect to be released with the UCSM 2.2 release. Once we have the provider available, now we need to enter the UCSM information to enable the bidirectional communication between the two managers. I already pre-provisioned the extension manager, and as you can see here, all I enter is the UCSM IP as well as the admin credential in this switch extension manager. We can also select different host group to apply this setting. In our cases, we only have one, but you can have multiple host group. And as you can see, we have this LS1 logical switch configured from the UCSM. And through this provider, this information is fetched into the SCVMM, and the server admin can readily to use this particular logical switch with the forwarding extension. Okay. So once we enable this bidirectional communications, the next step what we're going to do is actually we're going to create a local logical switch template, which allowed the administrator to use this logical switch over and over again across multiple Hyper-V hosts. We give the name of MMS-LS as this logical switch, and then we'll enable this SRLV functionality. And just a reminder that when you create a logical switch, you can only enable SRLV when you create this particular logical switch. Once the logical switch is created, you will now be able to go back and enable SRLV again. So, but there's an easy workaround, just create a new logical switch that replaces this one. And once we have that, we're going to select the forwarding extension, which will help us to bypass the hypervisor for individual virtual machine traffic. We're also going to fetch the uplink port profile information directly from the UCS manager to SCVMM. As you can see, since we have the provider available and it's constantly query the UCSM manager, all the port profile that we configure in the UCSM manager will be available, and you can choose directly from the uplink profile in SCVMM. Beside the uplink profile, virtual profile, you can also fetch from the UCS manager the first step we need to create is a port classification. So a port classification is really a local significant port profile that SCMM can be used over and over again across multiple virtual machines. In here, we give a name called MMS-VPP. And this particular port classification will be associated to the logical switch that we fetch from the UCS manager, and also associated to a virtual port profile that we previously created directly from the UCS manager. And that's how basically, how can you control the individual VM traffic in terms of QoS or network control directly from the UCS manager, because you can see the association here where we have a Bronzo VPP, which is a port profile created from the UCS manager, associated to the port classification in the SCVMM. An individual server admin can then apply this port classification to your virtual machine, and that's how your individual virtual machine traffic is getting controlled by the UCS manager.
Actually, maybe we can stop because I think we're running over the time. So at least we went through all the actual connecting the dots from creating from UCS manager going all the way to SCVMM. And I want to pause at this point, and after this is actually nothing but just deploying a VM and picking up the right extension and the right virtual port profiles so that the VM gets the right classification and the right QoS policy. Thanks for your patience, and at this time I want to open up for Q&A on the VMFX, N1KV, anything that we haven't touched on, we haven't answered.
Any questions you may have on either of the solutions? Please go ahead.
Just the release of the UCS2.
I think good.
Just wanted to find out the release.
Oh, that will be coming with UCS Manager 2.2. Sometime next year. Okay. End of this year. But provide you the bits for the beta.
So basically, your UCS at the moment, in this scenario, you manage 2 element managers.
Could you repeat that?
So without the provider, you just have to manage across 2 element managers. Like do the work in UCS, trunk it through, and then use VMM for everything else until that feature comes out.
Correct. Yeah. I mean, until the feature comes out today, how we can handle that is do everything in UCS Manager. Because we don't have the plugin for SCVMM to get to these port profiles SCVMM, we have something called MMC plugin that you can use, which will take the port profiles and directly hit the Hyper-V host directly with bypassing the SCVMM completely that we have today. Okay.
Any other questions, either on Nexus 1000V or VMFX?
Thank you very much.
Thank you very much, guys.
Thanks.